Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Nusradha Habimazlan, and for our project, I will explain about introduction. So first is background of the study. So gross domestic product or GDP is a key indication of any nation's economic progress. The expression generally refers to all labor generated inside a country's border. A country's GDP, which normally spans a year, determines that the total value of all goods and services produced there. For a very long time, past forecasting research has consistently shown that there is a positive association between a country's GDP and its tourist population. If a nation or region had a strong GDP, strong economic growth, excellent tourism infrastructure, and a safe environment, tourists will increase more quickly. So the two fundamental forecasting techniques that are frequently used in prior research are time series, and econometric forecasting. The time series forecasting model is one of the most often used forecasting model among academics and practitioners in the tourism sector due to its simplicity with the usage of univariate data. However, the econometric model is widely used to construct cross-sectional projections of visitor flow by studying the influence of independent variables such as currency exchange rates or the incomes of prospective visitors on tourism flow. So in GDP, three basic approaches are used to calculate GDP, which is the production approach, the income approach, and the expenditure approach. At the last, they will provide the same conclusion after the use of those methods. In contrast to the income approach, which considers the sum of all factor income created in the country, the production techniques accounts for the value supplied at each stage of production, according to study Wabomba 2016. However, the expenditure plan also accounts for export and government purchases of goods and services. Okay, so next I will explain about problem statement. So due to the GDP's propensity to fluctuate, predicting Malaysia's economic development has proved to be challenging. The precise measures of a nation's economic growth are still up for debate and are subject to range of other economic influences. As a consequence, researchers now often to study on the subject of GDP forecasting. According to earlier research, predicting for economic development differs to by nation since it is correlated with the impact by a wide range of macroeconomic variables, including foreign direct investment, which is FDI, exports, import, inflation, and many more. Because of they might affect economic circumstances, it is important to identify the variables that significantly influence or are directly related to economic growth. So time series and econometric models are the two basic forecasting methods that are often used in previous research. Due to its simplicity with the use of univariate data, the time series forecasting model is one of the most often used forecasting models among both scholars and practitioners in the tourist history. So next is our project objectives. Also in this study, we focusing on two main objectives to be achieved, which is first is to determine the best fitted forecasting model, either Box-Jenkins model or solo growth model, by comparing the error measure of mean square error, which is MSE, and mean absolute percentage MAPE for Box-Jenkins, and solo growth method by choosing the lowest error. So second, to forecast Malaysia's economic domestic growth using the best fitted forecasting model, either Box-Jenkins or solo growth model, by gain to analyze the economic condition in Malaysia.
Assalamualaikum, my name is Nurul Izzah and I'm going to present a detailed review of forecasting Malaysia economic growth. According to AFM Reduction 2020, in 2021 Malaysia has been the fourth biggest economy in Southeast Asia and the 39th largest in the world. Next, Malaysia has rapid economy discovered after the global financial crisis in 2009, said by Chen Tun in 2020. Furthermore, the ability in measuring Malaysia's economic growth is critical for setting the standard of living, assessing the consumption of products and services. To be highlighted, forecasting of GDP is important because it provides information on the economy and how to activate it. However, An increase in real GDP is considered as a good sign of economic growth. Mathematical and statistical method used in forecasting economic growth. For mathematical, the Bose-Jenkin method has been studied along with the Solar Group method for statistical. Bose-Jenkin method, introduced by George and Galvin in 1976 and known as a univariate time series model that often used in time series forecasting as stated by Lazim in 2021. This method allows to test the past economic model but modify the model in response to economic change over the time. The Bose-Jenkin method, also known as ARIMA model, and this model well-known univariate time series model used in time series forecasting. ARIMA model are type of linear model that may describe both stationary and non-stationary data according to Wilson in 2016. Second, Solar Group method was developed by Robert Solow and Travis Swan in 1956, and this model showed a long-term growth required technological advancement rather than saving. This method uses a neoclassical production function which is well-behaved exocrine and implies assumption of homogeneous good, exogenous labor augmented technical progress, full employment and exogenous labor force growth rate to present a model in which per capita output is dedicated by the exogenous saving rate, according to Arano and Jim in 2015.
In this study, the historical data for both models are collected from the official website of World Bank Data, NOMA and Department of Statistics Malaysia. For the Bose-Jenkins ARIMA forecasting model, the following data will be used are per capita income, population growth rate, and investment rate. The population growth rate is used as a proxy for the exogenous labor force growth rate. The investment rate is used as a proxy for physical capital, and the secondary school enrollment rate is used as a proxy for human capital. Thus, to conduct the analysis for Bose-Jenkins model, there will be a total of 35 yearly data of the respective variables, mainly the yearly GDP of labor force from 1970 until 2020. Meanwhile, for Solo growth model, different data set was used in finding the error value. In Solo growth model, the data used are saving rate, rate of capital depreciation, rate of technological growth, and exogenous growth rate of labor force. For this model, the data taken was extracted from 2010 until 2020. So the first model that will be used to forecast the GDP in this study is the univariate Bose-Jenkins model. Bose-Jenkins approach is synonymous with the general ARIMA modeling, in which to analyze the time series data. In this methodology, the basis of the Bose-Jenkins modeling approach consists of three main stages, which are model identification, model estimation and validation, and model application. Here, the ARIMA PDQ model is a combination of an AR or autoregressive model and an MA or moving average model with the value for D being determined by the level of differencing that is required to be converted into a stationary series. After the data becomes stationary, then the model estimation can proceed. The second model that will be used in this study is Solo model. The model is predicated on the assumption that GDP is developed using aggregate production function technology. In this methodology, Solo proposed using the neoclassical production function, whereby the growth in per capita income is caused by physical capital stock, the stock of labor, and technical change.
So in result topic, I will explain about the error measurement. So based on the table shown, the table show the error value for both methods, as shown in the table. For Bose-Jenkins method, which is ARIMA 220, which is the best model among all the ARIMA model. We choose ARIMA 220 because it is gave the MSE and MAPE value, which is 1189.9843 and 10.02396 respectively. Meanwhile, Solo growth model, the last year value gave 21,007.702. By considering the lowest error measurement for both methods, Bose-Jenkins method, which is ARIMA 220, gave the lowest error value for both MSE and MPE value comparing to the Solo growth model. So as the result, Bose-Jenkins method will be used in forecasting phases.
Here are the results for the first model, the Bose-Jenkins model. So the initial data study, which focuses on assessing the series' stationarity, is the first stage in identifying the proper ARIMA model. As a result, there are three ways to easily identify the series' stationarity. The trend of time plot may be seen first, which shows that the GDP series is non-stationary because it has an increasing tendency. GDP has been increasing over time, as seen in the figure on the left, with the greatest value being 264.681 billion US dollars in 2019. The series' development pattern implies that the series is not stationary. Second, a qualitative examination of the GDP level parallelogram. The autocorrelation function is quite positive and progressively dropping according to the parallelogram in the second figure. Meanwhile, just one notable spike is visible in the partial autocorrelation function at lag 1. The figure given implies that the underlying series is non-stationary. The examination of the stationary series' ACF or autocorrelation function and PACF partial autocorrelation function will be used to find suitable models to be fitted to the data series during model finalization. To find the best data, we need to do first and second differencing, and the stationary series employed in this research is at second differencing. To determine the substantial number of lags required according to the sequence of P and Q in AR and MA, the location and size of the spikes must be carefully considered. The figure on the left shows 5 significant spikes in the PACF plot at lags 1, 2, 3, 5 and lag 10, implying that the value of P or the order of the AR process can be either 0, 1, 2, 3, 5 or 10. Meanwhile, at lags 1, 5 and 6, there are 3 substantial spikes in the ACF plot, indicating that the corresponding value of Q or the order of the MA process can be either 0, 1, 5 or 6. It should be noted that the differencing order D is equal to 2, indicating that second differencing was used to achieve stationary series. In addition, the unit root test of augmented Dickey-Fuller ADF test was used to confirm the GDP series' stationarity. Instead of a simple observation, this test will produce numerical findings depending on the series' probability value. The results of the ADF test for the series is that the level where the null hypothesis was set to GDP has a unit root and the lag duration was set to be determined by Akaike Info Criterion or AIC. The table below displays the ARIMA PDQ model candidates for GDP computed in eViews using the OLS method. The methods were calculated using an adjusted sample of the estimation component, which spans from the year 1969 to 2007. The selected model's first criterion must be that both the AR and MA components are substantial. The ARIMA 220 model is the best fit for this series as shown in the table below. Although these models have the lowest AIC and SBIC value, they do not meet the first requirement. As a result, the ARIMA 220 model is the best, suggesting that it fits the data better than the other models. The results of the solo growth model identification and estimate phases will be shown in this section. Before applying the solo growth model, it has been determined that the dependent and independent variables are stationary. Microsoft Excel was used to determine the error value in the solo growth model. In this model, different data sets were used. Attributes used in this model are savings rate of capital depreciation, rate of technological growth, and exogenous growth rate of labor force. Equation 26, which can be referred to the full report, was used for this model and has been modified in the process due to the unavailable data. The new equation that has been modified is shown here. Each element in the equation was found separately by using Microsoft Excel to avoid error. Each one of the elements was shown in the table below.
Forecasting phase. First, choose the best model. In choosing the best model of forecasting phase, it can be true to be examined by selecting the best forecasting model and calculating its error management. For this study, 2 error measurement will be used through calculation in MSE and MAPE for Bot-Ranking method, ARIMA 220, and error value used in solo group method. After getting the best model, the selected model will use for forecasting phase. Forecasting phase will be used by eView software. Finally, forecasting measure GDP will be forecast for 3 years ahead, based on the selected base model, which is Bot-Ranking model, which is ARIMA 220 is utilized in forecasting the GDP. The figures show forecasting result for 2031 until 2023. Conclusion. By comparing both model methods, it is shown that the box-ranking methods give the smaller value of mean square error or MSE, which is only 1189.810 compared to the solo group realized value, which is 21007.00. Bot-checking model has made a better ability of accuracy to forecast GDP growth in Malaysia than solo growth method. The best model of bot-checking, which is ARIMA 220, uses it to forecast the GDP for 3 years ahead from 2021 until 2023. The value of forecasting for Malaysia GDP has been predicted slightly decreased from 2020 GDP value. For future recommendation, it is important to highlight research consideration for independent variable to contribute to economic growth in Malaysia market. Further, it is necessary to propose the inclusion of other factors. When applying the mathematical model, more data should be collected in the future to confirm the study validity and to accuracy better finding.